In exercise 7.05, we'll be looking at conversion graphs. Conversion graph is used to convert between different units, such as between metric and imperial units, or even between currencies in foreign currency exchanges. So in example 10, we have a perfect example of converting feet to centimeters, which are two different units used for length. Now, in the question, it says, Kylie is 5 feet tall. What is her height in centimeters? Well, the imperial length here is measured in feet, which is directly across horizontally. And she is 5 feet tall. So we're going to look at number 5 here, go upwards towards the line, and then we go across, and that will tell us how high she is in centimeters. Okay, and so our answer for that one would be, let me just double check, that is 152. Okay, because there are 5 squares here. Okay. So there's 5 squares, then 1 square would equal to 4 if 5 squares are 20 in difference. Okay, so it goes up by 4. So if there's 3 squares going upwards, that's 12 plus 140, which is 152. Okay, so that's the answer for the first question. Now, question B, it says the doorway is 85 centimeters wide. Convert this to feet, correct to 1 decimal place. Okay, right. So if we have a look at 85 centimeters, that's over here. So we said before that each square is going up by the number 4. So it's just slightly above the first square. So they have drawn a line going across and then going downwards after hitting the diagonal line. Okay. So going down here, we can see that the number here, each square here goes up by 0.1. Okay, since this is a difference of 0.5 divided by 5 squares evenly. So the third square above 2.5 will be the number 2.8 feet. Okay, so that's the answer for B, 2.8 feet. Right, then for C, the gradient of the line in this conversion graph is 30.5. What does this value represent? So if you have a gradient being 30.5, you can rewrite that as 30.5 over 1. And you know that the gradient is simply rise over run, which means that every single time we run by 1, which means every single time we go right by 1 to do with imperial length in feet, okay, so every 1 unit in feet represents this much, which is the rise, which is the metric length in centimeters. So basically 1 foot represents 30.5 centimeters. Okay? So say 1 foot equals to 30.5 centimeters. Right? That's what it means. Moving on. Exercise 7.05, conversion graphs. Let's have a look at question 2. The currency conversion graph converts between euro and Australian dollar. So euros is on the horizontal, whereas Australian is on the vertical. Now, just like before, how they had 5 squares here. Okay, this time it's still going up by 20. So 20 divided by 5 gives you 4. So each square, it goes up by a little bit here. It is number 4, okay, that it goes up by. When you look at it across, this gap here between 0 and 10 has 5 squares. So 5 squares is 10 units of euros, but 1 square would equal to 2. Okay, so you can just divide this by 5 and divide this by 5, and you get 1 square equal to 2 euros going across. So, all right, now what do? Convert each European price to Australian dollars. So we've got a smartwatch at 88 euros. So we're looking at basically where this is. Okay, so it's 88, which is 4 squares to the right of 80, because each square is 2, so 4 times 2 is 8, meaning that this will be 88. And then when we go upwards, like that, and then go across after hitting that line, we get this number here, which is going to be, I believe it is 128. Okay, this is $128. All right, now in the answers it says 127, but it does not matter because we're just reading off a graph and it will be slightly inaccurate. For question B, we've got a park entry, which is 36 euros. So 36 would be somewhere between 30 and 40, and it is 3 squares above the 30, because every square is 2. So 3 times 2 is 6, and added with 30 gives you that number as 36. So going upwards towards a line and going across, we've got a value here which is 3 squares above 40. 3 squares is the same thing as 3 times 4, which is 12 units above this number here, which is going to be the number 52. So it's 52 in Australian dollars. Then for question C, a mobile phone is 76 euros. So that's here. Okay, so that's 3 to the right of 70. Okay, or 3 boxes away from 70, sorry. So if you go upwards, hit that line, go across, that goes directly in between these two numbers, which is 100 and 120. So in between those two numbers is $110. Okay, so now you'll be able to do D, E, and F by yourself. Okay, you can do that now, or you can do that later. It's up to you. We're going to move on to 3. So the conversion graph from question 2 can also be used to convert small amounts. So say, for example, 46 euros is $66. So it's also true that 0.46 euros is 0.66 Australian dollars. And the way that works is that if you have 46 euros like that, and that's equal to 66 dollars Australian, right? What we can do here is the decimal places of these two values can move twice to the left, like that, so that this is also true. Okay? All right, so I've just copied down the graph from question 2, and the question, first of all, says, use the graph to convert each of the following prices to Australian dollars. So each of these are in euros right now, okay? So $1.2 euros is not on the graph. It's going, it's on the graph, but it's very, very tiny. So you wouldn't be able to use that number. So what we do is we get 10 times this number, which is 12 euros, and that would mean that it will be located 1 square to the right of 10, okay, because each square is 2. So if you go up like that, hit the line and go across, okay, you get somewhere between the 4th line and the 5th line. So remember, each square goes up by 4, so 4 squares will mean 16, and it's a bit above 16, so I'll just say it's 17. It's somewhere around there, okay? So it's not too accurate, but we can just say it's 17 Australian dollars for now. Right? And so if I was to calculate what this can of drink is, well, you just have to move your decimal place from the end to the middle, like that, just one spot. So that means this answer would equal to $1.70, around there, okay? It's an estimate. Question B, posting a letter is 0.80, okay? So what I've done here is I've times this by 100. You don't really have to actually, because you can actually get the number 8 out of that instead. I should have done that actually. Here we go. So let's have a look at the number 8, which is not here, but it's actually right here. Number 8 is actually just 4 spaces away from 0, because it's 4 times of 2. And then if I go across here, it is exactly 3 squares upwards, which is 3 times 4, and that's 12, right? Okay. Let me just double check that. So I know 8 is equal to 12, like that, which means if we move the decimal place 1, to the left like this, we would get 0.8 euros equals to $1.20. Now the answers don't really agree with this, okay, but let me just have a look at what else I could do. So if I was to go back to what I did before, which is seeing what 80 euros is, 80 euros is over here. Okay. Now, if I then go across like that, okay, what value would that give? Well, that's now 4 squares up. Okay, 4 squares up would mean that it's 4 times 4 above 100, which is 116. Okay, so this represents 16 in total, plus 100, which is 116. So again, see, it's never going to be 100% accurate. So this is now 116, which means now that if I just convert that back to 0.8 by moving the decimal places twice to the left, okay, then 0.8 euros would equal to $1.16. Okay, which is slightly off from $1.20. Okay, the answers say $1.15, but really each of these answers are correct just based on the graph. Okay. Now, there is a more accurate way of doing this, which is finding out the equation first based on that coordinate that's up there. But we don't really have to look at that at the moment. Okay. But for question 5, we do. So for question 5, it says, calculate the gradient of the currency conversion graph in question 2. Correct to 2 decimal places. What does this value represent? Okay, so last time when we did this question, okay, these answers were actually slightly inaccurate because we're just reading off the graph. Okay, and it does say to use the graph to help me convert that. But, okay, if I use this actual result here and look at how much did it rise by at the very beginning from 0, 0, this will be 144. Whereas the run here, okay, is 100, right? So there's my run, there's my rise. So if I got asked to find the gradient of this, okay, and what it represents, I would do m equals to rise over run, which is 144 over 100. And what that gets me is 1.44. Okay, now let's have a look at this in context. What does this actually mean? 1.44 is the same thing as 1.44 over 1. Okay, so each time I rise by 1.44, which is in Australian dollars, okay, so AUD, I can say that. I'm running here by €1. Okay? So if I was to be asked in exam how to actually define what the gradient means in this case, or what does it represent, it means every or each euro equals $1.44 in Australian. Okay,